Yeah, so last time we were talking about limits of complex functions. Um, we were able to see that the definition is not really different from, um, yeah, the definition is not really different from the way we do it in the real case, no? We still have this epsilon delta stuff, no? But there is just one thing that I'd like to mention about this limit for a complex function, especially this part, no? The part where we say that z approaches z naught. Okay. Um, in the real case, you have the real number line. No, if this is the point x naught, and when we say that x approaches x naught, there can be two particular directions that where x can take. No, either x can take these values or x can take these values, the values that are to the left of x naught and the values that are to the right of x naught. That's why we had the concept of right hand and left hand limit, no? Nung kayo'y nasa calculus na pangbata. On the other hand, sa complex plane, so we are now in the complex plane, when we say z approaches z naught, if this is the point z naught, the truth is it doesn't matter where z can come from, na wala kang left at right dito. Z can come from anywhere, literally anywhere. It can come from any direction. That's what I mean to say. Pwedeng i-approach z naught uh, in any direction. Or it could even be something like this, na pwedeng ang pag-approach niyo sa z naught is a, yeah, hindi talaga straight path, no? For example, if this is your z, it could approach z naught in this manner para siya nag-spiral towards z naught, no? So there are infinitely many ways to approach z. The truth is, just like in the real case, there was a real case, pag hindi nag-equal yung limit mo from the left at hindi sa limit mo from the right, when they are not equal, what is the conclusion? Sa real case, kapag hindi nag-equal yung limit from the left at yung limit from the right, anong conclusion?
The limit does not exist po.
Anyone? Yan. Yeah. Sabi ni Brill, the limit does not exist po. Correct. Kasi if the limit exists, no matter where you are, basta ikaw ay malapit kay x naught, whether it be from the left or from the right, dapat yung value mo ay malapit dun sa isang fixed na number. So kung hindi parehas yung ina-approach mong number from coming from two different directions, then the limit does not exist. That's an indication. Similar in the complex plane, if you were able to find two ways to approach z naught, let's say ito yung isang paraan to approach z naught, and then you get another way to approach z naught, and then yung limit mo dito sa direction na ito ay iba sa limit from this direction, no? Then we can also conclude that the limit does not exist. To tell you about such case, um, let's have this example. Let's consider the function z bar over z. No? The function z bar over z. So let's prove that the limit of z bar over z as z approaches 0 does not exist. So in this case, this is your complex plane. Saan magpupunta yung z dito sa 0? Okay, that's the 0. That's the origin. Of course, there are many ways to approach 0. But in order to prove that this limit does not exist, we only need to point out maybe two different ways to approach 0. Yet the value of z bar over z approach the values of z bar over z approach two different things, uh, coming from two different ways to approach z naught. What I'm telling you is, for example, now if you consider z to come from the x-axis, Na kunwari si z ay manggagaling sa x-axis. Okay, so let z be not 0. Anyway, si z ay i-approach lang naman si 0 talaga, di ba? Okay. Okay. If z is real, ano mangyayari? If z is real, then what can you say about z bar over z? Saan equal yung z bar over z whenever z is real? So because z is real, z bar is just what? Ang itsura niyan parang x plus yi bar over x plus yi, right? So parang x minus yi over x plus yi. But z is real, so ibig sabihin yung y ay 0. Kaya ang may iwanan dito will be just x over x. And because z is not 0, yung x mo hindi 0, so therefore this is just 1. Therefore we can say that the limit that z bar over z, or well, the limit of z bar over z as z approaches 0 along the real axis, kapag ikaw ay nasa real axis, is 1. Di ba? On the other hand, kapag naman si z ay i-approach si 0, but this time coming from the imaginary axis, let's say that's the, yeah, that's z, approach niya sa 0 coming from the imaginary axis. So if z is purely imaginary, then this time, ano itsura ng z bar over z? Similarly, ito ay x minus yi over x plus yi pa rin. Kaya lang, because z is purely imaginary, ang 0 dito ay yung x. Ang may iwanan ay minus yi divided by yi. And this time, as you can see, because y is not 0 as well, this is just negative 1. So it's constantly negative 1 kapag ikaw ay nasa imaginary axis. Therefore, yung limit ng z bar over z as z approaches 0 coming from, let's say, yi siya, okay, is negative 1. Ibig sabihin, if you are coming from the real axis, ang limit mo ay 1 kasi the function is constantly equal to 1 along this line. But when your z approaches 0 coming from the from the imaginary axis, so meaning to say z is purely imaginary, like so, no, di ba? Saan naman nag-a-approach yung z bar over z? Nag-a-approach naman sa negative 1. In fact, constantly, ang value mo along this line ay negative 1. Kaya ang limit mo ay negative 1. Because 1 and negative 1 are two different values. Therefore, the conclusion is that the limit does not exist. So, ito ang ating conclusion. So, the conclusion in this example is that the limit does not exist. Okay, pwede pa rin mangyari yan, kagaya yung case na yan sa uh, real line, na yung case na hindi nag-exist yung limit. Okay? Now, in terms of the real part and the imaginary part, we can say something about limits of functions. Hindi ba naaalala nyo ang function na complex can be expressed as u of xy plus I v of xy, where u of xy and v of xy are real valued functions on the variables x and y. Okay? So let us say that this function is defined on some punctured disk around z0 with these coordinates. Okay? And L is a number of the form u0 plus I v0. Then the limit of f of z is L as z approaches z0 if and only if these two functions, the function u approaches the value of u0 as xy approaches x0 y0, and the function v of xy also approaches the value of v0 as xy approaches x0 y0. Kaya lang, take note that this limit is na, kumbaga, yung limit ng f of z is equal to the limit of the real part, no, plus, no, simply saying this is what it means by that, no, yung limit ng f of z daw as z approaches z naught, kung yan ay nag-exist, equal dapat sa limit ng u of xy as xy approaches x naught y naught plus I times the limit of v of xy as xy approaches x naught y naught. I would just like, there is just one thing that I'd like to mention about this limit. Itong limit na ito, alam niyo yung meaning nito, no? Or hindi. Saan ba inaaral ito? I think sa Calculus 3 or Analysis 3. Recall from analysis 3, no? Kapag meron kang limit ng u of xy as xy approaches x naught y naught, ang meaning nito nung kayo'y nasa analysis 3 is the following, no? For every epsilon greater than 0, there exists a delta greater than 0 such that the difference between u of xy, kasi mga real numbers to and u naught can be made less than epsilon, no? Whenever, ano yung whenever, kailangan yung distansya na itong dalawang points na to is less than delta but greater than 0. But how do you measure the distance between these 2 points in the Cartesian plane, in the two-dimensional Cartesian plane? We use the distance formula, no? Kaya ganito yung itsura niyan. Okay? The only difference in the definition is the way we measure distance between these 2 points. Kasi we are now in R2, so yung distansya ng dalawang points na to is measured using this Euclidean distance formula. Okay, that's what we mean by a limit like this one. Kailangan pa ba natin tong ipakita? Hindi na, kasi paulit-ulit tayo dito, di ba? Kapag kinukuha mo yung limit ng buong complex number, no? Kinukuha mo yung limit ng real part, tapos kinukuha mo yung limit ng imaginary part, kailangan parehas yun mag-exist para masabi mo yung limit ng original na complex function ay mag-exist. So let's not let's not waste our time discussing this deeply, kasi basically alam niyo naman ang meaning ng limits na. There's also one thing that I'd like to mention, because in any analysis course, hindi matatapos ang isang analysis na subject without talking about continuity. Now, this is the heart of analysis. This is what separates analysis from any other subjects in mathematics, no? Continuity, the idea of continuity. So your complex function f is said to be continuous at z naught. Now take note that this z naught is part of the domain of f, meaning to say, may value dapat si f sa z naught. Yun ang unang-una. Dapat pag in-evaluate mo si f sa z naught, may value siya. Okay? If for every epsilon, there exists a delta such that whenever z is part of the domain and its distance from z naught is less than delta, dapat yung mga f nila, yung mga f ng dalawang points na ito, ang distansya ay less than epsilon. So meaning to say, if z is near z naught, dapat yung f of z is near f of z naught. And as you can remember from basic calculus, no, by this we actually mean three things, no? Itong condition na ito will mean three things, right? Number one, tatlo yan eh. Number one, dapat f of z naught exists. Number two, dapat the limit of f of z as z approaches z naught must also exist. At pangatlo, yung pinaka-importante, dapat yung dalawang numbers na yan ay nag-agree. Kumbaga, yung limit mo is actually the same as the functional value at z naught. When you evaluate f at z naught, dapat nag-agree yun. Hindi ba yan lang naman ang meaning yan? Kasi this is very similar to the way we define limits Ang nawala lang yung portion na may ganon. Kasi this time, because z is part of the domain, you now allow z to be equal to z naught. Kaya tinatanggal na natin yung irrelevant na inequality na yun. Okay? So this is continuity at the point z naught. Okay? So if f now is continuous at every point in S, no? At every point in S, we will say that f is continuous on S. Double ko yung S, okay? And in particular, kung si f ay continuous on its domain, doon sa buong domain, we will briefly say f is continuous. Pag narinig nyo sinabi ni Sir, f is continuous, without even mentioning where, no? Ang ibig sabihin ko noon, in context, si f ay continuous at every point in its domain. Alright? Again, the continuity can be restated using the real part and the imaginary part. So if you're going to look at the real part and the imaginary part, this function is going to be continuous if and only if the real part and the imaginary part are both continuous at the point x naught y naught, no? Where x naught y naught is are the coordinates of the complex number z naught when you think of the complex plane as the Cartesian plane, no? When you think of them as the same. Ano bang mga examples ng continuous functions? Ganun pa rin. Yung mga kinalakihan yung functions, mga polynomial functions. Ano itsura ng complex na polynomial function? Ang pinagkaiba lang naman ng complex na polynomial functions are the coefficients, no? This time, the coefficients are allowed to be complex, no? Yung mga an dito could be anything in the complex plane, no? Hindi, unlike before, yung mga an natin are real numbers. This time, the only thing different is the fact that the coefficients could be what? What do you call this? Complex numbers. Yeah. Now, this function, the function 1 over z squared plus 1, is continuous precisely at the points, just like before, no? At the points where the denominator is not 0. Kaya lang, di ba? Yung z squared plus 1 sa complex plane ay nagsi-0 if and only if z is plus or minus I. You know that very well. Okay? So, pag sinabing precisely at all points z different from plus minus I, sabihin, anywhere else, the function will be continuous kasi it's just a ratio of two polynomials. Basically, the limit rules still applies, kaya ganon, kaya mangyayari yan. Na yung mga algebraic limit rules. Now, there is just one thing that I'd like to mention about this example, kaya ako yan pinakita. No? What is that? Ganito. Kasi yung real counterpart nito, ano yung real counterpart? Yung real counterpart nito, yung function na f of x equals 1 over x squared plus 1. If you recall from elementary calculus, this is continuous everywhere in the real number line. Diba? It is continuous anywhere on R kasi sa real number line, yung x squared plus 1 ay hindi nag-zero. Iba ngayon pag nasa complex plane ka na kasi this time, even yung x squared plus 1, in this case, z squared plus 1, nag-zero na siya. And it could give us a problem. No? Kaya you are now going to consider all the complex numbers as possibility. Yun yung pinagkaiba. Unlike before, yung function na ito ay continuous everywhere. But in the complex plane, this function has two discontinuities. And they are found at the numbers I and minus I. Okay, what else? Yung mga complex function na to, yung z bar, yung resi, yung imz, no? Yung mga functions na ito are continuous everywhere in z. Why? Let's check one by one. Halimbawa yung z bar. Kasi alam nyo, pag kinampit yung z bar, kuha ka ng kahit na anong z naught sa complex plane, anywhere, okay? Pag kinampit nyo yung z bar minus z naught, pag kinampit mo yung distansya na itong dalawa, right? Pag kinampit mo yung distansya niyan dalawa, property of bar, magiging ganyan. But we know very well that the absolute value of z bar is just the absolute value of z. Hindi nagbabago yung magnitude mo when you take the conjugate kasi you're just reflecting the number along the about the x-axis, di ba? Kaya ito parehas pa rin sa absolute value ng z minus z naught. Kaya ang gagawin mo dyan, pag nag-let epsilon ka, ang kukunin mong delta ay epsilon din. Kasi kapag ito yung less than delta, ito yung less than delta, di ba? Magiging less than delta, epsilon din siya. So ito ay less than epsilon. Okay? Ganon din naman yung sa resi tsaka imz kasi halimbawa yung resi naman, if you take the resi minus re of z naught, property ng re, it's the real part of z minus z naught. Now what do we know about this? This is less than or equal to absolute z minus z naught. And just like before, kapag kinuha mong epsilon yung delta mo rin, kapag yung delta mo ginawa mong epsilon din, ito ay magiging less than delta, so that will be less than epsilon. Ito ay less than epsilon. Kaya continuous yung resi sa z naught. Similar for imz, no? Yun din yung reason kaya magiging continuous siya. So these complex functions are everywhere continuous. Now, ano ba mga bagay na alam natin about continuous functions? So these are the things that we know. These are the following are equivalent statements. Whenever f is continuous, these three things are happening. Pag kumuha ka ng arbitrary point in the plane at meron kang sequence na nagko-converge sa z, yung image nun, nung image ng sequence mo nagko-converge din sa f of z. Meaning to say, if you get a sequence here that converges to a point z here, let's say ito yung z, ito yung z, ay sorry, ito yung z1, z2, z3, and so on, nagko-converge dyan, no? Dapat pag kinampit mo yung images nila, dapat nandito yung f of z1, nandito yung f of z2, and so on, f of z3, and so on. This sequence of points will continue. Dapat yan magko-converge sa kung ano man yung image ng z. No? Dapat yan magko-converge. In other words, continuity preserves convergence. Number 3, the inverse image of an open set is also open. You know this very well, no? From topology. All of these things are proven to be equivalent. And also, the inverse image of closed sets are also closed, no? So totoo pa rin yung mga properties na ito. And these are different ways to define continuity, no? Kasi they are all equivalent, no? Kung alin man dito ang magamit natin, halimbawa nakakita kayo ng function na continuous later, nakakita kayo ng open set, o pag kinuha mo yung inverse image no ng conclusion, because f is continuous, the conclusion is that f inverse is still open. Now, why do we want continuous function so much? Because there are things that are so nice about continuous functions. Number 1, kung connected man yung set na S, yung image nun under a continuous function is also connected. No? Kung si S naman, yung domain mo naman ay compact, yung image ng isang compact set under a continuous function is also compact. Okay? Yung theorem number 1 at yung theorem number 2 can be ito yung pinanggalingan ng tinatawag nating extreme value theorem. No, that the function achieves a real valued function with compact domain achieves a maximum and a minimum. No? Yung number 1 naman, yung connectedness na nakakapag-preserve ng connectedness ang isang continuous function. Dito naman ang galing yung intermediate value theorem kasi sa real case, ang image ng isang interval ay isang interval. Kaya meron kang IVT tsaka EVT. Sila, itong dalawang theorem na ito yung IVT at EVT mo in higher analysis. No? This is how we say it in higher analysis. Kapag ikaw ay nasa calculus na pangbata, intermediate value theorem ang tawag dito. Ito ang tawag dito ay extreme value theorem. Now, how about in the complex plane? Sa complex plane, ang f of z hindi real number kasi. So, hindi mo pwedeng pag-usapan ang maximum at minimum. But meron tayong paraan to still talk about maximum and minimum. Instead of talking about f of z alone, na ang pag-uusapan natin yung absolute value ni f of z. Kasi this time, the absolute value of f of z is what? Is real. Kaya kung si f of z ay continuous, yung absolute value ng f of z ay continuous din, kung ang domain mo ay compact, yung absolute value niyan will achieve maximum and minimum values at certain points in S. Okay? Kung saan na-achieve yung maximum, ang tawag din yung argmax tsaka argmin. Or huwag na natin pag-usapan yun. Anyway, in particular, what it says is that if your domain is compact, the function is continuous because the absolute value achieves both maximum and minimum values. It only says that your complex function is a bounded function. Meaning to say, yung f of z mo, maharangan mo ng isang m in absolute values for all z in S. This is what we mean in S. This is what we mean by the word bounded. Okay? So anyway, these are just some of the nice things about continuous functions, and you know how powerful these results are. You have experienced the power of this in earlier analysis courses. So far, anong mapapansin ninyo? Talking about limits and continuity, the definitions are all similar. And basically, kung ano yung mga results ninyo sa real, nag-extend siya naturally in the complex plane, no? There's really nothing different about this one. So ang tanong natin, bakit tayo nagkaroon ng complex analysis, no? Why do we need a separate subject for complex variables when these definitions are very similar, the results are very similar? The truth is, maghihiwalay, no? Maghihiwalay ang real analysis at complex analysis sa usapin ng differentiability. At yun yung ating lesson for today. Okay? So, for today, we are going to talk about, ang haba na introduction natin, no? Kasi hindi natin natapos yung mga yun last time. Yeah. So, this is the part where, this is the part where complex analysis will go in separate ways with against the real analysis, no? The idea of being differentiable and the idea of the derivative. Although the definition is still the same as in the real case, but you will see that there will be results later na will tell you that complex derivatives are quite different, no? Ano yung sinasabi ko? In fact, even today hindi natin yun magagawa kasi marami tayong pag-uusapan about derivatives in this lecture. Yung sinasabi ni sir na maghihiwalay yung complex tsaka real, hindi pa natin may establish yun for this lesson, but you will see it later. Pero marami tayong mapapag-usapan dito. Kaya makinig kayo mabuti, no? This is the point where everything will be different from before. Kaya dito tayo mag-focus. Okay? The idea of differentiable functions and the idea of holomorphic functions. Ang holomorphic function ay bago sa pandinig ninyo, no? Right? It is something new. Pag sinabing holomorphic, it is better than differentiable. It is something better than differentiable kasi kapag holomorphic, hindi ka lang differentiable sa isang point, differentiable ka pa on some neighborhood of it. Kumbaga, hindi ka lang sa isang point differentiable ka pa dun sa paligid ng point na yon. Yung sabihin natin ng holomorphic. So yung pagiging holomorphic ay kombinasyon ng pagiging differentiable at mga open sets. Na may kinalaman yung mga open sets dito. Alright, so let's look at the definition of being differentiable. So again, as you can see, nothing much is different. Yeah. Kaya nga ito'y kinagulat ng sambayanan na bakit gano'n, no? Ang definition ay parehas naman, yet yung behavior ng mga complex function when it comes to differentiability is quite different. Bakit ba? Kaya na nabigla ang sambayanan nung nalaman yan. That's why nagkaroon tayo ng subject na tinatawag na complex analysis. So anyway, before we can talk about differentiability, meron tayong requirement. Dapat para maging differentiable ka sa z-naught, first of all, dapat yung function mo ay defined on some open set containing z-naught. Kumbaga, hindi ka lang dapat may value sa z-naught, dapat may value ka pa at points surrounding z-naught. Di ba pag sinabing open, may mga points pa sa paligid ng z-naught na members ulit ng set. So meaning to say, hindi ka lang define sa z-naught, define ka pa doon sa mga points na nakapaligid sa z-naught. Yun yung ibig sabihin ng unang condition na ito. Okay? So when can we say that f is differentiable at z-naught? Napakadali. Kung yung derivative na ito ay nag-exist. Ano ba ibig sabihin ng derivative at z-naught? It is still the limit of the quotient as shown in the definition. Meron bang bago? Wala. Ito yung f of z naught, di-divide mo sa z minus z naught, and then take the limit as z approaches z naught. Okay? Kung nag-exist yung limit na ito, no, differentiable. At yung limit na yun, ang tawag dun ay yung derivative ng f at z naught. Ang pinagkaiba this time, well, ang unang pinagkaiba, ang feature na ito, this time, yung quotient na ito, hindi mo pwedeng interpretin to as slope, no? Unlike before, it could be interpreted as slope kasi it's really a slope. This time, it's not a slope kasi wala ka namang line. Remember, ang mga complex functions cannot be graph, no? Wala siyang graph na kagaya nung nasa real. So parang ang derivative, you cannot even imagine what that number is. Kasi parang, kumbaga kung ito yung z plane, ito yung f of z plane, no? Parang, kumbaga, kung ito yung z naught, syempre meron kang z. Dapat they belong to the same open set. Tapos ito yung f of z, ito yung f of z naught. You could not even, identify ano yung f of z minus f of z naught. Hindi yung real number. Yung f of z minus f of z naught ay complex number din. Di ba? Kukunin mo yung difference na ito. Can we say that it is the distance? No. Ang distance kasi ay yung absolute value. Pero wala namang absolute value doon sa definition. So, hindi natin pa pwedeng interpretin as the distance. Na? Unlike in the real case. So, to get that quotient, you just simply subtract these two. Divide that difference by the difference of z and z naught. Anong meaning nun? I don't know. Basta, we just copied the definition in the real case and see whatever will happen in the complex case. Okay? But again, because the definition is similar, there are still things that still holds. You will see that there are still familiar things that will hold. Pero hindi tayo doon magpo-focus, gaya ng sabi ko. Magpo-focus tayo doon sa meron yung complex differentiables na hindi natin napapag-usapan sa real differentiable. Again, before I talk about those differences, let me just mention that this definition or this limit, if it exists, can be written differently, no, in another way, using the delta z notation. Pero pwede nyo pa rin gamitin yung delta, dati delta x yan, di ba? And delta z lang. You can still use the delta z notation. Ang pinagkaiba lang ng dalawang limits na to, dito yung z nag-approach sa z naught, dito ang bida hindi z. Kasi wala kang z dito. Ang bida dito ay yung delta z. I-replace mo yung f of z ng f of z naught plus delta z minus f of z naught Tapos yung denominator mo magiging delta z. Now, these two are equivalent kasi if you look at the substitution, no, if you let delta z to be z minus z naught, isolve mo yung z dito, pag sinolve mo yung z dito, that z is z naught plus delta z, kaya ito napalitan ng ganon. And also, as you can see, as z approaches z naught, yung difference na to nag-approach sa 0, kaya yung delta z, tinitreat natin as something that goes to 0. So, did you understand the definition? Meron ba kayong nakikitang difference so far? Di ba wala? Naintindihan mo yung definition? Okay. Sige, dadahan-dahanin natin kasi yung mga susunod na makikita nyo ay hindi ka nais-nais. Okay. Another notation that I'd like to introduce is ay yung DDZ notation. Okay? Kapag si g of z ay function, tapos yung derivative ni f at any point z ay nag-agree sa g of z, ibig sabihin si f prime of z equals g of z for all z, then we can also write g of z as the derivative of f of z to say that ginagamit natin itong operator na ito, yung ddz operator, right? Just like before, alam nyo na ito. No? So there's really nothing to talk about here. Example, the standard extensions of polynomial functions in the complex plane, yung mga complex polynomial functions, are still differentiable everywhere. In particular, the power rule still holds. Ano yung sabihin ng power rule? Yun, yung derivative ng z to the n is nz to the n minus 1. Yun nga lang ha, this time, yung exponent natin na n is only restricted where? On the integers. Wala pa tayo nung z to the 1 half. We haven't talked about z to the 1 half. Kasi kung 'di ba kung sasabihin niya, sir, 'di ba sa real square root of x lang yung x to the 1 half? Yes, kasi sa real kasi may unique na positive square root yung x kung si x ay positive, kaya nagiging function ito. Sa complex plane, dalawa palagi ang square roots, 'di ba? Tatlo palagi ang cube roots, apat palagi ang fourth roots. Kaya hindi talaga ito function, kaya hindi natin sinusulat yan ever. Yeah, there are branches of these roots. Pag-uusapan natin yan later, yung mga fractional exponents. For now, yung exponent dito ay integer. So, halimbawa nakakita kayo for example ng 5iz cubed plus 2 plus I, z. O kung nakakita kayo ng ganyan, paano kinukuha yung derivative niyan? Kagaya pa rin dati. Ang pinagkaiba lang ngayon, yung mga I, iti-treat nyo as constant. Okay, walang pinagkaiba ha. Walang dapat pag-awayan dito. Kasi the definitions are still the same. So that's still 2 plus I. Okay? Naintindihan niyo, walang dapat na pag-awayan dito kasi the definitions are still the same. So we will expect some of the formulas to be the same. Also, I just like to mention about this restriction. Kapag si n kasi ay negative, halimbawa z to the negative 2, di meron kang 1 over z squared. Totoo pa rin naman yung power rule na yan. Paging ganyan siya, pag nag-power rule ka, tama ba ako? Yeah, maging ganyan siya pag nag-power rule ka. May restriction lang dito, of course, that z cannot be 0 kasi nga nasa denominator yung z. Okay? Ayan, magbigay tayo ng example na hindi similar. Halimbawa ito, look at the function f of z equals z bar. As a function, anong ginagawa ng f of z equals z bar? Ang ginagawa nito, the way I imagine this actually is as follows. Ito yung real axis. Ito yung nasa taas niya. Kulayin ko ng dilaw ha. Ito yung nasa ilalim niya. Kulayin ko ng blue. Pag si f of z ay in-apply ko Si Z-bar, in-apply ko dyan sa plane na yan. Ang kanyang image ay yung real axis hindi magbabago kasi ang conjugate ng mga reals ay sarili nila, di ba? Pero this time, yung mga yellow lines na yan will be transformed here. Nasa ilalim na sila ng ano, no? Ng x-axis, while yung mga blue lines na yan ay nasa ibabaw na. Ganyan yung ginagawa ng f of z equals z bar. So, imaginein mo, you can imagine na meron ka ditong, for example, meron ka ditong figure na R. Ang image niya after the transformation is like that. Ganun yung ginagawa ng f of z equals z bar. Now, we will prove that, imagine nyo, napakasimple lang na reflection ito. Reflection lang ang tawag natin sa geometry. No? This reflection is not differentiable at any point. No, imagine niyo, ang bilis ng example. Napakasimple ng example ng isang function that is not differentiable at any point. Now, what's so fascinating about f of z equals z bar? F of z, bago natin ipakita yan, no? What fascinates me about this example, nung una ko itong nakita, is the fact that sa f of z equals z bar, gaya ng sabi ko kanina, this is continuous everywhere. But nowhere differentiable. Imaginein mo. It is continuous everywhere, but it is nowhere differentiable. Sige nga sa real analysis, maghanap ka ng ganyang function. Maghanap nga kayo ng function that is continuous everywhere sa real case, no? Pero hindi, never naging differentiable lang. Ang meaning na rin sa real case, di ba? Parang yung graph mo dugtong-dugtong, pero never naging smooth yung function mo. So in R, parang the way we think about this is parang gagawa ka ng function na ang graph ay dugtong-dugtong naman pero never magiging smooth, never magiging straight. Parang ganyan-ganyan, no? Ganyan-ganyan na-imagine natin. But in reality, this is not an example of such. Kasi kapag zoom in mo yan, pag yan ay zoom in mo, may makikita ka dyan na parang ganyan, di ba? May portion yung graph ko na naging straight siya, therefore differentiable yun. Ang differentiable kasi meaning makinis, walang mga sharp turns. So dapat kung gusto mong nowhere differentiable yan, dapat kahit i-zoom mo, let's say zoom ko yan, dapat ang makikita mo ganyan ulit. Naintindihan niyo ba? Parang dapat ang graph mo ay fractal-like. Pag sinumod at magulo pa rin. Do you see do you remember the ano ba yung example kanina? Yung, anong pangalan nito? Yung M, anong set yung M? Anong set nga yun yung pinag-usapan natin dati sa Mandelbrot set? Di ba yung gilid ng Mandelbrot set, as you keep on zooming in, wala kayong nakikita talaga na tahimik siya. As you zoom in, laging may portion siya na may lalabas na naman na bagong feature. Right? Yeah, that's an example of a fractal like, no? Kagaya nitong continuous ever nowhere differentiable sa real, hindi ito madaling hanapin sa real case. Pero sa complex case, it's already given. It's just a function z bar. Just imagine, no? To give you an example of a real function that is everywhere continuous but nowhere differentiable, may magpapaktak sa inyo ng may ipapakita ko sa inyo, may share ako sa inyo, i-share ko yung aking browser. Okay. Did the view change to the browser view? Nag-change ba ito browser view?
Yes po.
Okay, i-search nyo yung Weierstrass function. Yan. If you try to look at the Weierstrass function, yan, mag-ano na, Wikipedia na lang tayo, sige. I think this is quite reliable naman kahit papaano. Yan. Ang Weierstrass function, ganyan yung itsura ng graph niya. Nakikita niyo yung graph niya on the right. Yan. Kung babasahin niyo yung kanyang description, it's an example of a real valued function that is continuous everywhere but nowhere differentiable. It's a fractal curve. Eh no, ganyan, ito yung itsura niya, yung graph niya. When you try to look at a corner, for example, this corner, and you zoom it in, makikita nyo ulit yung sarili niya, paulit-ulit lang. Inuulit niya yung sarili niya in small portions. Did you see that? Naintindihan niyo ba yung sinasabi ni Sir na inuulit niya yung sarili niya at very small portions. And if you keep zooming in, walang magbabago. You will see the same thing. Anong definition niya? Ito yung definition niya. It's a series of functions. It's an infinite series of functions. It's actually a Fourier series. It's a sum of curves. It's an infinite sum of curves. Yun nga lang, yung sum ay hindi naging kaaya-aya ang itsura. No? Yun yung kanyang definition. Mapoprove nyo na nag-exist sa saan nyo ba pinag-aralan ng uniform convergence and whatever, no? I don't know. Saan nyo pinag-aralan yung uniform convergence, pointwise convergence, mga ganon? Where are you studying this? This is not studied, of course, in a basic calculus course, no, yung pangbatang calculus, kasi it needs more advanced mathematics. Yan. So, ganyan kahirap maghanap ng ganyang example na function sa real case. Whereas, imagine niyo sa complex plane, napakasimple ng ating example. Ang ating example ay yung f of z equals z bar. Sige nga, let's see why this is not differentiable anywhere. Kasi kapag kumuha ka ng arbitrary point in the complex plane, let's say z0, meron ba ako dito explanation? Yan. Pag kumuha ka ng z0 anywhere in the plane and you try to calculate the derivative, of course, the derivative is a limit. Ito sa nanggaling to. Ito yung f of z. Okay? Sinulat ko na ganyan. Right? It is equal to this limit. Okay? Equal siya dito. Limit ng delta z bar divided by delta z as delta z approaches 0. Paano natin nasabing hindi nag-exist yung limit na yan? Ay, nakita na natin yan kanina. Actually, ginawa ko siya kanina dito. Hanapin natin yun. Ito yun. Iniba ko lang, papalitan nyo lang yung z dito ng delta z. If you replace z here by delta z, you see that that is exactly the same limit as before. No? Again, to reiterate, why does this limit does not exist? Why does this limit not exist? Ayan yung reason. Kasi nga yung delta z bar over delta z ay may value na 1 kung si delta z ay real at may value naman na negative 1 kung si delta z ay purely imaginary. Just like before. Kaya hindi mo mapopoint out ang limit. Kumbaga, on a neighborhood of 0, may value yung function mo na 1, may value na negative 1, somewhere else maybe different na naman yung value. Did you understand? No? Yun yung ating idea. So, definitely, it's not going to be differentiable because this derivative does not exist. Hindi nag-exist yung derivative na ito. At any point z0 in the complex plane. Although it is continuous everywhere. Naintindihan ninyo yung example ko na ito? Naintindihan ninyo bakit hindi naging differentiable anywhere to? Okay. The following rules for differentiation will still hold. Ano to? Ito yung derivative ng sum of the derivatives. Kapag may constant, the constant will just go out. The product rule, ang tawag nyo dito, product rule. Diba? Ito naman ang tawag nyo dito, quotient rule. All of these things will still hold. Of course, some of them has, in particular, in number 3, it has a restriction. Siyempre, bawal yung g of z not mag-0. Otherwise, yung fraction na to will not ever have meaning. Unless you consider infinity part of the discussion. Di ba pag nag-divide tayo ng zero sa complex plane, nagiging infinity. We still have the chain rule. The chain rule is just about the composition of two functions. Parang two differentiable functions. Parang kapag meron kang f na differentiable, tapos si g na differentiable, in-apply mo siya sa f of z naught, di ba? So ito yung g circle f. Sabi nito, kung ito daw ay differentiable sa z naught, kung si g ay differentiable sa f of z naught, anong meron? Yung composition na ito ay differentiable sa z naught. In fact, yung derivative ng g circle f at z naught, kasi nga differentiable, so that may derivative, is just the product of the derivatives of g at here and the derivative of f at z naught. So you always think about this diagram para maalala niyo yung chain rule. Okay? So that's the chain rule. When we talk about chain rule, tandaan nyo, ang nasa isip nyo dapat, composition of functions. Kapag sinabing chain rule, differentiable ba ang composition ng dalawang differentiable na function? Ang sagot ay oo. Okay? Chain rule. Ito naman, iba naman tong example na to. Just ko, no? Tingnan nyo to. This function this time is differentiable only at the origin. Naloko na, no? Kaya nga sinasabi ko sa inyo, medyo weird yung mga complex function pagdating sa differentiability. Unlike sa real case, yung mga ganyan kasimpleng itsura na function, most likely it is still well behaved. Pero pagdating mo sa complex analysis, no, yung function na to, differentiable only at one point and nowhere else. Just imagine that. But because you see this is just the square of the absolute value function, it is everywhere continuous. So this is everywhere continuous, but it can only be differentiable at one point, only at the origin. So to illustrate why, no? For example, let's look at the derivative of f at 0. Ano ba ito? Siya yung limit nito. Diba? It's the limit of z as z approaches 0 nung f of z minus f of 0 divided by z minus 0. In-evaluate ko na para sa inyo. Ayun yung absolute z squared minus 0 divided by z minus 0. Now, ano yung limit nito? Kasi yung naalala nyo, yung absolute z squared ay parehas sa zz bar sa complex plane. Diba? Identity natin yan before. So, pinalitan ko yung absolute z squared ng zz bar. Why did I do that? So, I could cancel the two z's. Like so. Kasi si z hindi naman zero yan eh. Pero pwede nyo i-divide because z only approaches the value of 0. So, may iwanan na z bar. And because z bar is continuous everywhere, ano yung limit niyan? Ang limit niya yung value niya lang, which is 0 bar or it's just 0. So as you can see, the derivative of f at 0 or at the origin is 0. Okay? Ang tanong, ano yung derivative niya anywhere else? Kailangan hindi mag-exist, no? How do we show that the derivative anywhere else does not exist? So to do that, I will take an arbitrary point different from 0. I will call it z naught. Kasi, mali itong 0. Ito yung mali. Yeah. If f of z is differentiable, kung nagkataong differentiable ito at z naught, si z naught hindi 0, di ba? Then, yung function na ito, magiging differentiable. Paano ba saan ba nanggaling to? Nanggaling to dito sa identity na to. Okay? Kung z ay hindi 0 kasi, pwede kong isolve yung z bar dito. Ang z bar ko will be modulo z squared divided by z, correct? Kung ito ay differentiable kasi sa z naught, yung z naught hindi zero. Yung function na ito, magiging differentiable siya kasi quotient siya ng dalawang differentiable. Naintindihan nyo? Right? Pero hindi. Bakit hindi? Yung z bar kasi in the previous example is proven to be nowhere differentiable. Did you understand? Did you understand? Kaya yun ganon. Kumbaga, kung magiging differentiable ito at z naught, yung z bar magiging differentiable din. Kasi yung z bar ay quotient ng absolute z squared divided by c. And by the previous example, yung z bar na ito is nowhere differentiable. That's a contradiction. So, dapat hindi ito differentiable. Okay? So, as you can tell, itong function na ito is differentiable only at z naught and nowhere else. Okay? Ano pa yung mga bagay na alam natin about differentiable functions? Ito, classic ito. Na kapag si f ay differentiable sa z naught, ano siya? Automatic continuous siya. Once na ma-prove mo ang differentiability sa z naught, automatic ang continuity. But again, there are functions which are just continuous but not differentiable. Example, z bar. Okay? Why is that the case? Kasi if you will take any z different from z naught, I can express f of z as follows. Check nyo, no? Because z is not z naught, this is not 0, this division is allowed. Pag sinimplify mo yung right hand side, makikita nyo, magka-cancel to, may iwanan f of z. Yeah? Tama ba yung Tama ba yung equality ko? Can you check the algebra? It's correct, no? So, if I now take the limit of both sides as z approaches z naught, if z approaches z naught, ito constant to, magiging f of z naught. Ito, magiging f prime of z naught kasi nga differentiable eh. Diba? Kasi ito magiging mag-approach sa 0. So itong product na to mag-approach lang sa 0. Ang may iwanan, f of z naught. So what's left here is that the limit of f of z is f of z naught as z approaches z naught. And that is exactly what we mean when we say that f is continuous at z naught. Kaya ang differentiability ay mag-i-imply palagi ng continuity. Again, meron tayong example na function which is just continuous. This is continuous. But it is nowhere differentiable. Kaya yung converse ng theorem na yan ay definitely false. Okay? Alright. Ito na. Let's now talk about real and imaginary parts. Let's say si f of z, sinulat ko siya in the rectangular form, uxy plus ivxy. Okay? Let us say that this function is differentiable at z naught with coordinates x naught and y naught. The question is, what can be said about the functions u and v? Anong masasabi natin dito sa dalawang functions na to? Take note that hindi ito kasing simple na kapag differentiable to, differentiable din yung dalawa. Kasi magkaiba sila ng notion ng differentiability. Kapag function of two variables, medyo complicated yung definition ng differentiability nito. Hindi porket nag-exist yung tinatawag yung partial derivatives noon, automatic ng differentiable. Pag multivariable functions, ang differentiability is more than just the existence of partial derivatives. Hindi porket nag-exist yung partial derivatives mo, differentiable na. Did you study that? Um, kung naging estudyante ko kayo ng analysis 3, tinuro ko yun. Naalala kong tinuro ko yun. Kung hindi, hindi ko alam kung sinong teacher niyo analysis 3 kung na-touch niyo yung part na iyon. Hindi, yung mere existent, di ba kapag may more than ka ng one independent variable, two variables and up, hindi lang isang derivatives meron ka. Meron kang partial derivative with respect to x, partial derivative with respect to y, o kung meron ka pang z, d with respect to z, dalawa lang naman this time. Not because these partial derivatives exist, hindi ibig sabihin nun na differentiable na yung function mo. Iba ang differentiability sa higher dimension. Mamaya makikita niyo kung ano yung sinasabi kong differentiable. Okay? May mga examples na nag-exist yung partial derivatives mo at a given point pero hindi siya differentiable at that point. Okay? Okay, so what can we say? So, kapag sinabing differentiable, ang meaning talaga natin nun, yung limit na ito yung nag-exist. No? But this time, I'm going to use the delta z notation because I find it more convenient. Pero tandaan nyo, ang ibig sabihin ng delta z dito ay delta x plus I delta y. Okay? Alright. By letting delta z approach 0, kasi yung delta z nag-approach sa 0, di ba? Again, meron kang some complex number na nag-approach sa 0. So, I'm going to do the same thing as before. Ang gagawin ko, first case, i-approach natin yung 0. Yung delta z i-approach yung 0, pero manggagaling siya sa real axis. Nandiyan yung delta z. Okay? Pag nasa real axis ka, dito sa dalawang terms na ito, sino ang 0? 0 yung y. So, yung delta z mo is just delta x. Anong mangyayari dito sa expression na ito? Ito ang mangyayari. Yung limit mo, magiging delta x na lang, kasi nga yung delta y ay 0. Ay, ano nangyari dyan? Masyadong marami nangyari, no? Sige, let me elaborate this for you. Hindi ko muna isasulat. Let's take a scratch paper so you can see, no? Ano yung sinasabi ni sir. So again, si f of z ay uxy plus I vxy. Okay? Delta z is delta x plus I delta y. Ano pa ba? Si z naught is x naught plus I y naught. Okay. Yan yung mga given. Okay? So if I take f of z f of z naught plus delta z minus f of z naught all over delta z, yun ba yung ginagawa ko? Let's check. Yeah. I'm doing this specifically. Okay. So let's go back to scratch. If you consider this ratio, what will you get? Ang ibig sabihin ng f of z naught plus delta z, yung z naught mo, dinadagdagan mo ng delta z. So in this case, yung x mo, gagawin mong x naught plus delta x, tapos yung y mo, gagawin mong y naught plus delta y. But then again, along the real axis tayo, so ang meaning yung delta y mo is just fixed to 0. Okay? So yung fraction na to, magiging ganito. Ito siya, di ba? F of z. Papalitan mo nito. U of x naught plus delta x, comma, y naught. Supposedly, lalagay ko plus delta y. The problem is, it's not a problem. But delta y is equal to 0. Kaya hindi ko na, may ganito ka pa, supposedly. So, hindi na natin isusulat yon. Plus, huwag nyo kakalimutan, dalawang part siya. Okay? Yan yung f of z naught plus delta z. isusubtract ko ngayon yung f of z naught, it is going to be u of x naught y naught plus I v of x naught y naught. All of this divided by delta x. Supposedly, meron pa akong I delta y. But then again, I will just erase this because that is just 0. Kaya yung denominator ko, delta x na lang. Nakuha nyo? And then, anong gagawin natin next? Pagsasamahin ko yung dalawang terms na ito, tsaka yung dalawang terms na ito, yung mga real part, tsaka yung mga imaginary part. So, magiging ganito siya. Yung mga real part, magiging u of x naught plus delta x, comma y naught, minus u of x naught y naught. Okay? Yan yung unang part. Minus I. May I ka dito, di ba? Para sila may I. V of x naught plus delta x, comma, y naught minus v of x naught y naught. All of this divided by delta x. And then, meron kang dalawang terms dito. I-divide ko pareha sa delta x. Tapos, kapag yung delta z nag-a-approach sa 0, yung delta x ay nag-a-approach sa 0. Si delta y ay 0, naka-fix. Diba? Kapag ito kasi nagsi-0, fix naman to sa 0. So, si delta x ay nag-a-approach sa 0. Kaya itong expression na to, maging ganito. Where's that? Kaya ito, limit yan. Diba? Maging ganyan na lang siya. Ito yung unang term. Ito yung pangalawang term. Do you get that? Nasundan nyo ba? In-expand ko dito sa Scratch. Ito yun, no? Ito yung unang term. Minus ba to? It should be plus, no? It should be plus. Yeah, it should be plus. Mali ako ng algebra. Ito ang minus. Correct. Kasi ito plus. Nasundan? Okay? Okay ba tayo? Okay. So, kukunin nyo ngayon yung limits nito. Kaya lang, from analysis 3, saan equal yung mga limits na ito? To what are they equal to? To what are they equal to? Teka lang, hanapin ko yung ipapakita ko sa inyo, ha? Aha. Saan equal yung dalawang limits na yan? Do you agree equal yan sa, equal yan sa partial derivatives, no? Ito equal, yung unang limit, it's equal to the partial derivative of u with respect to x evaluated at x naught y naught plus I partial derivative of v with respect to x at x naught y naught. Now, sinusulat nyo rin ng ganito yan kung minsan. Okay? Ito yung another way of writing that. Derivative pa rin yan. Kasi bakit partial derivative yan with respect to x? Kung mapapansin nyo kasi, only the variable x has changed. Yung y mo dito hindi nagbago at all. Ang nagkaroon lang ng change dito ay yung x, yung y ay fixed. Tapos dinivide mo siya sa relative change doon sa x. Kaya siya ay partial derivative. Ano bang interpretation natin dito? Ayan, hinanap ko kasi kanina yung lecture ko about partial derivatives. Hanapin natin yung bakit ganyan yung definition. Ayan. If you're going to look at this, ito yung definition natin ng partial derivative with respect to x. Lecture ko to sa Math Analysis 3. Inano ko lang. Kinuha ko. Dito si f of xy, yung function. Okay? Yung definition ng partial derivative with respect to x, yung x coordinate lang ang lalagyan mo ng plus delta x. Tapos di-divide mo siya ng delta x. And then you take the limit as delta x approaches 0. Now, what does that mean? Yung f of xy, kung i-imagine mo siya as the graph of this red surface, no? Dahil naka-fixed yung y value mo sa b, parang ang gagawin mo, kukunin mo yung plane na y equals b. Ito yung plane na y equals b, yung blue. Kapag yan ay nag-intersect sa surface, it will generate a yellow curve, like in the picture. Correct? Kasi yung y mo naka-fix na sa si b, so kung gagalaw man si x, dito na lang siya gagalaw sa yellow. Naintindihan ninyo? So, ano yung partial derivative mo at the point AB? Kunwari, ito yung AB. Naka-fix naman sa BCY, no? Ito yung point where the x-coordinate is A. That partial derivative is going to be the slope of the tangent line along the yellow curve. So parang it's as if in the direction of this yellow curve, in the direction of the plane y equals b. On the other hand, ang partial derivative mo naman with respect to y, si x naman yung naka-fix, si y naman yung gumagalaw, so yung plane, yung cutting plane mo ay baligtad naman. Your cutting plane this time, pag nag-add ka naman ng delta y, yung cutting plane mo ay, in this direction. The cutting plane will generate a curve if it intersects the surface f of xy, no? Tapos at the point AB, the partial derivative with respect to y, it represents the slope of that tangent line. Naintindihan ninyo? Ito yung definitions natin ng partial derivative. Napag-aralan nyo ba ito dati? Dapat. Okay, sa Math Analysis 3. Kaya, balik tayo sa complex analysis. Ito ay equal, no, yung limit na ito ay equal sa sum ng dalawang partial derivatives na yan na may typo error kasi ito ay I du. Okay? So, mali-mali ako ng pagkaka-type. Yung una, yung partial derivative ng u with respect to x. Yung pangalawa, I times the partial derivative of v with respect to x. Now, anong ginawa ko dito to be able to come up with this? I let delta z approach 0 along the real axis. Okay? Ang susunod na gagawin ko, I will let delta z approach 0 along the imaginary axis. So, sabihin, kung kanina dito ka nang gagaling, yung susunod na case na gagawin ko, dito ko naman paandarin yung delta z. Okay, ano mangyayari in that case? In that case, yung delta x mo naman na mag-0. Ang delta z mo will be now replaced by I delta y. Okay? Ngayon, kung yung limit na ito yung nag-e-exist, dapat whether you approach 0 from the real or 0 from the purely imaginary axis, whether wherever you approach 0 from, dapat pare-parehas yung lalabas na limit. Right? Okay. Tingnan natin. Yan. You can also write the partial derivatives in this way if you're not comfortable with writing this. If that is too big. Now this time, I will let delta z approach 0 by restricting delta z to move along the imaginary axis. This case, ito naman yung 0. Ano naman ang mangyayari doon sa derivative natin? Ganito yan. Ito na yung mangyayari. Si x naught, 0 nga kasi ito, no? Maging x naught lang siya. O, ayan, nag-add ka ng delta y. Ganon din dito. Except yung denominator mo, instead na delta x plus I delta y, magsisiro yung delta x, may iwanan I delta y. Correct? Nasusundan ninyo. Okay, ito na yung trick dyan. Yung mga I na to magka-cancel. How about the I there? Sa first term. Meron kang 1 over I dito. Sa first term, meron kang 1 over I. Ano ba ang 1 over I? Anong reciprocal ng I? Di ba pwede ka mag-multiply ng minus I? Ganyan yun, di ba? minus I over 1. So the reciprocal is minus I. Ang reciprocal ng I ay minus I, kaya yung I sa denominator, kung gusto mong itaas, gagawin mong minus I. Ganito siya. Tingnan nyo. Ano yung pinagkaiba ngayon? This time, itong V na part ang nauna kasi naging real na siya. Itong part na ito, napunta dito sa kanan, tapos nagkaroon ng negative sign kasi nga yung I na nasa ilalim, inakyat mo. Yun nga lang, lalagyan mo ng minus sign kasi ang reciprocal ng I ay minus I. Did you understand? Nasundan niyo yung computation. Sige. Now, to what is this limit equal to? Yung unang term, ano yun? Partial derivative yan with respect to y. Yung pangalawang term, partial derivative naman din ito. Ay, sorry. May mali na naman akong pagkakatype. Wala na tong I. Diba? Na-divide na nga eh. Okay? Yung second term is I, partial derivative ni u with respect to y at the point x naught, y naught. Okay, ganito no? So kapag yung delta z manggagaling sa, pupuntahan si origin coming from the real, itong itsura niya. Okay? Pag si delta z manggagaling sa imaginary axis, ganito itsura niya. Because this derivative exists, dapat yung dalawang nakuha natin equal. No? Ano ba yung kanina? Ito yung kanina. Yung derivative mo, we're computing the same derivative. Kanina, ux plus ivx. Yan yung kanina. Ito yung along the real. Okay, along the real. Ito yung along the imaginary axis. If we are computing technically the same thing, ibig sabihin, dapat yung mga complex numbers na to, parehas ng real part at parehas ng imaginary part. Did you understand? Okay? So, i-compare natin ngayon yung mga real parts nila at saka yung mga imaginary parts. Comparing the real parts and the imaginary parts, dapat equal itong dalawa. At the same time, equal ito dito sa negative ng uy. So, this is what I get. At the point x naught, y naught, what do we have? Dapat yung u with respect to x mas equal v with respect to y. Ito yun. At saka yung u with respect to y, ito, dapat equal sa negative ng v with respect to x. Okay? These two partial derivatives, these two equations must hold at the point x naught. Saan pa tayo nakarating? Ano ba yung tanong natin? Di ba ang tanong natin, kung si f ay differentiable sa x naught, anong masasabi natin sa u at saka sa v? Ito yung masasabi natin. Their partial derivatives exist and they satisfy these two equations. These two equations in complex analysis are what we call as the Cauchy-Riemann equations. They are named after Cauchy and Riemann because sila yung dalawa ang promotor ng complex analysis. Dahil sa kanila kaya kayo may ganitong subject ngayon. To summarize what happened in these computations, ito yung ating napala. Okay? Nasagot natin yung tanong. No? We were able to answer the question. If f of z is u plus iv, and it is differentiable at the point z naught with coordinates x naught plus iy naught, then at the point x naught comma y naught, the partial derivatives of u and v both exist and they satisfy the Cauchy-Riemann equations. Ano yung Cauchy-Riemann equations? Ito yung dalawa. Dalawa yung nasa-satisfy ng u and v. Ux must be vy. Tandaan nyo ito, ux is vy. Uy is minus Vx. Did you understand? Ux is Vy. Tama, Ux is Vy. Uy is minus Vx. I don't have any other mnemonics, no? Basta tatandaan nyo sa isip nyo, Ux is Vy, Uy is minus Vx. Wala akong may share sa inyo ng mnemonics para mabilis nyo ma-remember ito, but to actually memorize. Dalawa lang naman yan eh. Yung mas maikli, Ux, Vy, o ganito, sulat nyo, UV, XY, by XY, YX. Pag XY, tama yung order, equal. Pag YX, baligtad yung order, lagyan nyo ng minus sign. Kaya Ux is Vy, at saka Uy is minus Vx. Naintindihan ninyo? Naintindihan yung Cauchy-Riemann equations? Okay. Furthermore, meron tayong formula para sa derivative ng f. Ano yung formula sa derivative ng f? So, nanggaling yan? Nanggaling yan dito. Ito yun yung kanina. F prime, tingnan nyo to. F prime, tingnan nyo, F prime is Ux plus IVX. O kaya, ito pwede nyo gamitin ito. Ito yung pag ina-approach coming from the purely imaginary axis, you have Vy minus Iuy. Okay? Yun yung theorem na ito. Ux plus IVX, or you can use Uy minus Ivy. If you want the partials with respect to x, then you can use this. But if you want the partials with respect to y, you can also use this. Anyway, equal yung dalawang yan because of the Cauchy-Riemann equations. Okay? Mamaya ipapakita ko sa inyo how to apply the Cauchy-Riemann equations. Okay? How to apply the Cauchy-Riemann equations in example. Siguro mag-break tayo kahit mga 10 to 15 minutes. 10 minutes, okay na break ba yun? Ipopause ko muna yung recording. So we're back now. So again, the reason why we have the following theorem is because we were asking, just in case, for example, f of z is differentiable at the point z0 with coordinates x0 plus y0. We were asking, anong masasabi natin about the real and the imaginary parts u and v respectively? How does u and v behave? No? What we have found out after the long computations that we did is that yung mga functions na to as functions of two variables x and y, their partial derivatives both exist at the point x0, y0, and at this point, the partial derivatives satisfy the so-called Cauchy-Riemann equations, which are the following. Ux is equal to Vy, and Uy is equal to minus Vx. Furthermore, we were able to find out to express the derivative of f in terms of these partial derivatives. It is equal to Ux plus Ivx, or Uy minus Ivy if you want to use the derivatives with respect to y. Now, I want you to take note that the contrapositive of this theorem is as follows. No? If u and v are two functions in variables x and y, they do not satisfy the Cauchy-Riemann equations at the point x not y not. Kung isa dito ay hindi na satisfy or parehas, no? Then we can say as a conclusion that the function will fail to be differentiable at the point z0. Intindihan niyo yun. Kung hindi na satisfy ito, ibig sabihin nun, hindi differentiable dun sa z0. Okay. As a matter of illustration, I want you to consider the function z squared. Last time, kinompute natin yung real part at saka imaginary part nito. Again, paano nakuha itong mga functions na yan? We were able to take that by taking the square of x plus yi. Yung z, papalitan nyo lang ng x plus yi, and then take the square. You will get x squared plus 2xyi plus y squared I squared. Yung I squared ay negative 1, so magiging ganyan. I-separate yung real at imaginary part, so you get the following. Alright? Nasundan nyo ba yan? Now, we already know that z squared is a polynomial function, therefore, it is everywhere differentiable. So, by the previous theorem, dapat yung u na ito, tsaka yung v na ito, they must satisfy the Cauchy-Riemann equations everywhere in the Cartesian plane R2. So, kung tatawagin natin u of xy, yung x squared minus y squared, tapos tatawagin nyo namang v of xy, yung 2xy, you can see that anong magiging partial derivative ni u with respect to x? If you're going to compute the partial derivative of u with respect to x, what do you get? Paano ba kumuha ng partial derivative with respect to x? Anong partial derivative ng x squared minus y squared with respect to x? (2x). Paano nga nakukuha ito? You just do ordinary differentiation where all other variables aside from x will be treated constant. Kasi nga, di ba dun sa definition ng partial derivative, si y hindi gumagalaw, fixed lang, so parang constant lang siya. Ang iniisip natin gumagalaw lang ay si x. Kaya, dinidifferentiate lang natin siya with respect to x. Kaya ang sagot ay 2x. Ano naman ang vx? Ano naman yung vx? Hoy, ano ang vx? Can you do the vx? Check nyo mabuti. Anong vx? Anong partial derivative ni v with respect to x? Ito ang v of xy. Ito ang v of xy. Hindi kasama yung I. Oh my gosh. Okay. Ganyan siya, di ba? 2xy. I-imagine niyo si xi constant. We are differentiating with respect to y. If 2x is constant, y, ang function mo na lang, magiging bale 2x times derivative with respect to y. 1 yun, di ba? Kaya 2x lang ang sagot. Hindi ba? Ay, x pala, sorry. Ano ba sinasabi ko? Sorry. With respect to x muna pala tayo kasi ang liit ng x, hindi ko nakita. So dito, ang constant ay y. So lalabas yung 2y, dinidifferentiate mo with respect to x, si x. Kaya ang sagot ay 1. Kaya 2y ang sagot. Tama kayo, 2y. Next, ano naman ang uy? Ano yung uy? Compute nyo yung uy. Tingnan nyo. Minus 2y. Very good. How about vy? (2x). So what do you notice? What do you notice? These two are equal and these two are negative of one another. In other words, this is to illustrate that if your function is differentiable, yung mga Cauchy-Riemann equations for all xy ay nasa-satisfy. Ano yung Cauchy-Riemann equations? Ayun o, ux is vy and uy is equal to minus vx. on the entire Cartesian plane. Did you understand? Na nakita nyo equal? Equal tong dalawa, kasi itong dalawa ay negative ng isa't isa. That's the Cauchy-Riemann equation. So, yun yung theorem natin. Furthermore, may formula tayo sa derivative, di ba? The derivative can be can be calculated using the partial derivatives with respect to x. Ang formula, ux plus ivx. Okay, kakomputin ko. Tignan nyo. Ano yung ux? Coming from your computation, that's 2x. Ang vx naman ay 2y. Okay? Now, as you can see, this can be re-expressed as 2 times the quantity x plus iy. But remember, x plus iy is just z. Kaya f prime of z is just 2z. Parehas ba siya doon sa natutunan yung derivative ng z squared? 2z? Naintindihan niyo? Did you get this example? Oo. That's the power of the Cauchy-Riemann equations. Okay? Ayun yung theorem na sinasabi natin. Kapag si f na may u plus iv na ay differentiable at a point, yung u and v na satisfy yung Cauchy-Riemann equations. Furthermore, may formula kayo sa derivative ng f, which is ux plus ivx. As you can see, nagmamatch siya doon sa saan siya nagmamatch? Nagmamatch siya doon sa ating alam na derivative talaga ng z squared, which is 2z. Okay? Tingnan nyo naman yung function na f of z equals z bar. Okay. What do we know about f of z equals z bar a while ago? Kanina pinag-uusapan natin to. What do we know about z bar as a function? Kanina, yung z bar, anong natutunan natin about z bar? Yes, it's nowhere differentiable. It's everywhere continuous but nowhere differentiable. Oh, tama yung not differentiable, pero mas accurate yung nowhere differentiable sa not differentiable. Kasi pwedeng not differentiable ka at a point or not differentiable at a certain region. Pero mas ma-accurate yung description na nowhere differentiable to say that it is at any point not differentiable. Naintindihan nyo? Okay. So kung papalitan natin si z ng x plus yi, ang z bar ay x minus yi. Just like so. So in this case, ano yung u at saka yung v natin? Ang u of xy natin ay yung real part which is x. Ang imaginary part natin ay minus y which is that, the v. Okay? Now, if you're going to compute the partial derivatives of u and v, so this is what I get. So these are all the partial derivatives that I get. Tingnan mo, ux is of course 1, uy is 0 kasi wala ka namang y dyan. Diba? Vx is 0 and vy is negative 1. As you can see, at no point xy can the Cauchy-Riemann equations be satisfied. In particular, yung una, yung ux never mag-equal sa vy for all xy. Kasi tignan nyo, ang ux ay 1, laging 1 ito ay negative 1. So, hindi sila mag-agree at any point. Okay, in the Cartesian plane or in the plane R2. Therefore, by the previous theorem once again, because the Cauchy-Riemann equations will never be satisfied at any point xy, as a conclusion, the function f of z equals z bar is not going to be differentiable at any point z in the complex plane. So this is yet another proof of the fact that f of z equals z bar is nowhere differentiable because the CREs when I say CR is, the Cauchy-Riemann equations are never satisfied at every point, at any point. Naintindihan ninyo? Although satisfied na yung isa, yung uy is minus vx. Diba? Pero ito yung sinasabi ko, kailangan, pag isa lang dun sa dalawang equations na yun, hindi na nag-hold, no? Hindi na magiging differentiable. Okay. So f of z equals z bar is nowhere differentiable. Now may tanong ako, hindi ko na isulat yung tanong dito, but let me just write the question over here. Let us say that at x naught y naught, u and v satisfy the Cauchy-Riemann equations. Kunwari, at the point x naught y naught, they satisfy the Cauchy-Riemann equations. The question is, must the function f, written as u plus iv, be differentiable at z naught, which is x naught plus iy naught? So the question is asking you about the converse of the previous theorem. Kapag ba nasasatisfy yung Cauchy-Riemann, let's say, enough ba na sabihin na ay nasasatisfy ni u and v yung Cauchy-Riemann equations at that point? Therefore, the complex function u plus iv is going to be differentiable at z naught, which is x naught plus iy naught. Is that enough? Yung masatisfy yung Cauchy-Riemann equations and declare that the function is differentiable? What do you think? What is your guess? What is your guess? No, no? Kasi alam niya kung yes ang sagot dyan, hindi ka maitatanong. Tsaka kung yes ang sagot dyan, di sana dun sa theorem, nilagay ko na if and only if. Yes, normally, the answer to this question is no. So kung no, dapat may example tayo. No? Ano example ang hinahanap natin? We wanted an example of an f where u and v both satisfy the Cauchy-Riemann equations at a certain point, but the resulting complex function is not differentiable at that corresponding point. So let us see an example. In fact, I have here. Yan. Let's consider, asahan nyo na ang itsura ng function ay medyo artificial kasi nga pipilitin natin masatisfy yung Cauchy-Riemann equations pero hindi siya differentiable. So for example, ang definition ko na f of z is like this piecewise. So f of z ay z to the fifth divided by absolute z raised to the fourth power whenever z is not zero, and it is just zero whenever z is zero. Prove that the real part and the imaginary part of f, ito yung u at saka v ha, iba lang yung turing ko ngayon. Kasi wala na kayo nakikitang u and v doon sa aking definition, okay? Prove that u and v satisfy the Cauchy-Riemann equations at the origin in the Cartesian plane, but the derivative of f at 0 in the complex plane does not exist. Ito example that serve as a counterexample for the converse of the previous theorem. So ang sinasabi ni sir, hindi porket satisfied ang Cauchy-Riemann equations at a point, hindi guarantee yun na yung complex function mo ay differentiable doon sa corresponding point sa complex plane. Did you understand? Naintindihan niyo ba yung bakit natin binibigay yung example na ito? Naintindihan ninyo? Sige na, huwag na kayong tamaring sagutin kasi gusto kong na-check kung kayo kung nakikinig ba kayo. Sige. Alright. So let's do this. Ang gagawin natin, write F as U plus IV para hindi natin tinatawag na re tsaka im yung U at tsaka yung V. Okay? Okay. So paano natin ipapakita that the function that the U and the V satisfy the Cauchy-Riemann equations? Kung titignan nyo, di ba ang unang step, normally we let Z be X plus YI and then we calculate F of Z, F of X plus YI. Kaya lang this time, makikita nyo, the definition is quite hard. Kung papalitan mo to ng X plus YI raised to the fifth power, you don't like raising X plus YI to the fifth power in rectangular form. That's not really efficient. So, meron akong technique na gagawin. And then, sundan nyo ha. Tignan nyo yung gagawin ko. Ay, sorry. If Z is real, when I say Z is real, zero yung zero yung Y. Sabihin real, no? Pero hindi zero. So remember, yung zero is, well, dito tayo titingin. Kukunin kasi natin yung limit as Z approaches zero. So hindi ko ididikit si Z sa zero. Okay? So ibig sabihin nito, if Z is real but not zero, ibig sabihin nandun ka sa x-axis pero hindi ka tumidikit sa origin, then what can you say about f of z? Ang f of z natin, bali f of x lang. Tapos 0 ang y. So, mangyari dito, maging x to the fifth over absolute x to the fourth. But x is real, so ang absolute x to the fourth is just x to the fourth. Diba? Sa real number line, ang absolute x to the fourth is just x to the fourth. Kaya ito magiging x lang. Okay? To be more transparent, lalagay ko dito 0 plus x plus 0i para makita nyo na si y ay 0. Okay? Tama ba? Tama. So therefore, anong therefore? Ano yung real part at saka imaginary part ng f of z kapag si z ay nasa real number line? Therefore, pag si x ay nasa real number line, ang y mo dun 0 di ba? So, isi-0 muna yung y. Ang u of x0 mo, ang real part nito ay x, pero ang imaginary part niya ay 0. Walang I na lumabas, di ba? So, ang vx0 ay 0. Tama ba? So, if this is true for all x in R different from 0, ang tanong, ano yung partial derivative mo at 0? Ano yung ux at 0, 0? By definition, kinukuha natin yung limit as delta x approaches 0. Ano bang definition nito? Bale, kung u sa 0, no? So, 0 plus delta x, comma 0, minus u of 0, 0 divided by delta x. Yun yung definition ng partial derivative with respect to 0. Ang mangyayari dito ngayon, u of delta x, comma 0, ito yung equation na meron tayo. So, magiging delta x na lang siya. Ito naman, u of 0, 0, 0. Di ba? Tapos kasi 0 lang naman yung function mo whenever z is 0. So, 0 lang yun. Divided by delta x. So, that is 1. Tama? On the other hand, ano naman yung vx natin at 0, 0? Ang vx naman, it's the limit as delta x approaches 0 nung u of 0, comma, 0 plus delta y. Ay, sorry. Mali ako. V pala tayo. V of 0 plus delta x, comma 0 minus v of 0, 0 divided by delta x. But what is v of delta x comma 0? 0 always. Kaya ito yung limit ng 0 minus 0 over delta x. This is 0. So, nakuha na natin to. Ito ay 1. Ito ay 0. Let's compute for the partial derivatives with respect to y. Kakopy ko to, gawa ko ng bagong page siya. Okay, ito tayo. Using my technique, ang ginawa ko, yung y nga, sinilo ko na, no? Anyway, yeah. Kukunin ko yung partial derivative with respect to x sa origin. So, sinilo ko muna si y. Yun yung technique para mapasimple niyo yung, ano, yung UNV. Hindi mo kailangan mag-expand. Okay? Alright, so let's now take the, ano bang nawawala pa? May UX na may VX, nawawala yung UY tsaka VY. So let's take the partial derivatives with respect to Y. So ganitong gagawin ni sir. This time, si Z ay padadaanin ko naman sa Y axis. So 0 si X. Ganyan. Again, here Y is real but not 0. Ibig sabihin, nasa imaginary axis ka kasi may I. Okay? But still, hindi mo ididikit sa origin. Ang tanong, ano yung f of z this time? Ang f of z this time ay f of 0 plus iy. Ito yung definition mo kasi si z is not really getting equal to 0. So, anong mangyayari? Yung z mo iy. Para kang may iy to the fifth divided by iy to the fourth, absolute value to the fourth power. Ang I to the fifth, anong I to the fifth? Ang I to the fifth is I to the fourth times I. Di ba? Tama ba? Tama ba? Ang I to the fourth ay 1. So, ang I to the fifth ay I. Kaya ito ay Y to the fifth divided by ang absolute value ng IY. Ang absolute value kasi ng I ay 1. Kaya ang may iwanan lang dito, Y to the fourth. Okay? Y to the fourth. Tama ba? Actually, absolute Y to the fourth. Pero dahil real number si Y, at naka-fourth power, whether may absolute value or wala, it doesn't really mean different. Kahit na wala yung absolute value. Ang may iwanan bali ay I, Y. Aha. Ang lumabas sa f of z, kapag si z ay nasa imaginary axis, ay purely imaginary rin. No? So therefore, ano yung u of xy? Therefore, ano yung u of 0y? 0 na kasi si x eh. Ang u of 0y ay 0 kasi wala ka namang real part dito. Pero ang imaginary part mo ay y. Yung katabi ng I. Kung ano yung katabi ng I, yun yung imaginary part. So using a similar computation just like before, magpa-follow na ang partial derivative with respect to y, yung 0y, parang yung derivative mo na lang yung with respect to y. Tapos yung vy, yung 0 comma y is just 1. Para kasi dinidifferentiate mo na lang to with respect to y. Parang ganun yung idea niyan. So meron ka ng apat na values, no? Ano yung apat na values? Ayan, ikakahon ko, no? I-arrange natin siya. Ang ux at therefore, at the origin, anong value ng ux? uy, vx, vy. Ano nga yung apat na yan? At the origin, ux is 1, vx is 0, uy is 0, and vy is 1. So as you can see, at the origin, CR is are satisfied. Ano ba yung CRE? Ano nga yung CRE? Ux is Vy and Uy is minus Vx for your information. At the origin, the Cauchy-Riemann equations are satisfied. Okay? Meron tayong may pinapagawa pa yung example na ito. So, yun na, nagawa na natin to. But, we will prove that the derivative at zero does not exist. How do we do that? Ganito yan. Dali ah. Okay. Finally, we show f prime of 0 does not exist. To see this, why it doesn't exist, ganito. Kapag kumuha ka ng z different from 0, at kinampit mo yung f of z minus f of 0 divided by z minus 0, ito yung kukunin mong limit mamaya. Okay? Ang f of z mo, because z is not 0, is z to the fifth divided by absolute z to the fourth minus 0 divided by z minus 0. And when this is, what we call this, when this is simplified, ano mangyayari? Ang mangyayari, bale, ang magiging z to the fourth over absolute z to the fourth. Okay? May gagawin akong trick to simplify this. Itong absolute z to the fourth ay absolute z squared times absolute z squared. Diba? Anong alam nyo sa absolute z squared? That is zz bar. Diba? So this is zz bar, zz bar. So, because z is not 0, we can cancel this. Ang may iwanan bale, z over z bar squared. Okay? Ulitin ko ha, z over z bar squared. Nag-simplify na lang siya sa ganyan. Were you able to follow these computations? Nasundan niyo ba yung computation? Okay. Ginamit ko dito ang critical dito itong part na ito. Wag ang absolute z squared, hindi yan parehas sa z squared ha. True lang yun kapag real. Sa complex plane, ang absolute z squared ay zz bar. Okay, do not forget that. Okay? So ito yung mangyayari. So, you only need to do is to prove that this limit does not exist. Meron tong kamukha kanina. Kaya lang yung proof na ito, iiwanan ko na sa inyo as an exercise. Gayahin yung ginawa ko kanina. Tingnan nyo how do we show. Kasi in fact, kamukha na ito yung kanina. Yung kanina lang z bar over z. I think we're looking at z bar over z in the previous example. No? This time, it's z over z bar quantity squared. So, I want you to show that this limit does not exist to complete the proof. Now, syempre, asahan nyo, yung example na to medyo makabagbag damdamin yung computation na ginawa natin kasi this is a counter example. And this example really look like is a made up of function. When say made up function, ginawa ito, sinadya itong ganyan yung definition para masatisfy yung Cauchy-Riemann equation at the same time, hindi siya maging differentiable. So in short, the converse of the hindi porket nasa-satisfy ang Cauchy-Riemann equations at a certain point, yung complex function mo is differentiable on that corresponding point. Okay? Ayan. The converse of the CRE theorem is false. Ang tanong dito, let's say nasa-satisfy na ni U and V yung Cauchy-Riemann equations. So then, nasa-satisfy na. So, di ba, In general, hindi mo pwedeng i-conclude na si U plus IV ay differentiable. Okay. Ang tanong, ano kayang kulang sa pagsasatisfy ng UNV? Ano yung requirement para yung UNV, maliban sa nasasatisfy ni UNV yung Cauchy-Riemann equations, ano pang additional conditions kaya ang pwede natin i-impose para si F ay maging differentiable, mapuwersa siyang differentiable? Okay? Yun yung ating aalamin. Next. Sa usapin ng functions on two variables, kasi tingnan nyo, no? Ito yung function. Natural na magiging differentiable siya kung yung u at saka yung v parehas differentiable. Pero gaya ng sinabi ko kanina, for a function of several variables, sa mga multivariable functions, hindi porket nag-exist ang partial derivatives mo, automatic differentiable ka na. Hindi yan kagaya ng single variable na functions. Pag single variable, basta may derivative ka, differentiable na. Pag multivariable, hindi porket nag-exist ang mga partial derivatives, it doesn't mean na naging differentiable na. Kasi for example, I can show you one, ano bang pwedeng made up function. Halimbawa, imaginein mo yung function na ganito ang itsura. Ito yung graph niya kunwari. Imagine niyo parang bubungan to ng bahay na pa-cross. Paano ba ito-drawing ng maayos to? Na-imagine nyo, parang meron akong bahay, kapag tinignan mo siya from the top, yung bahay parang cross. Parang ganyan. Kasi yung bubungan mo, ito yung bubungan mo, no? Na-imagine nyo to kapag ito yung top view, ito yung view mo from the other angle. Can you imagine my picture, the 3D picture that I was able to show you? Okay. Ano itong pinapakita ko sa inyo? Kunwari yan yung graph ng function na let's say f, ayokong gamitin yung f eh. U of xy. Kunwari yan yung graph ng u of xy. Kung mapapansin nyo, ang partial derivative mo at the origin with respect to x tsaka partial derivative mo at the origin with respect to y ay parehas 0. Why did I show that? Why did I say that? Paano ko nasabi yun? Kasi if you look at the tangent lines, if you look at the slope in the x direction and the slope in the y direction, they are perfectly flat. Itong mga lines na to ay they are perfectly level to the ground. Therefore, their slopes are both 0. So this is an example of a function where the partial derivatives at the origin is 0. Pero tingnan nyo, can we say that the function is differentiable at the origin? Ano bang ibig sabihin natin ng differentiable? In a 3D case, pag sinabing differentiable ang surface, ang nasa isip natin, something like this. Something like this. Kailangan makinis yung graph mo at this point. When you say makinis, pag makinis? Pag hinawakan mo, wala kang mararamdamang gusot or lukot doon sa surface at that yellow point. Pero when you look at this, no, lukot yan eh. Pag tinignan mo yan from the top, meron yung fold dito. Yung may fold yan dito, di ba? Merong crease. Did you understand kung ano sinasabi ko? Meron yung lukot. Parang on top view, parang ganito siya. So, ito yung parang cross, no? On top view, so ito yung gitna, meron yung fold na pag ganun dito. Diba? Pero dito may ano siya. Do you imagine that? So this is not going to be differentiable, not a differentiable surface. Whereas ito ay differentiable, ito ay hindi. So anong meaning natin ng differentiable kapag nasa 3D, no? Kapag kagaya nito nasa u of xy. How can we quantify or paano natin masasabi na differentiable ang isang function pag u of xy yung function ninyo? Ang ating isa sa mga pamamaraan is by looking at tangent planes. Ang gusto natin, kasi kapag differentiable kagaya na itong pangalawang example ko, when you look at a plane tangent to this surface, makikita nyo, yung tangent plane nyo tsaka yung surface nyo, hindi masyadong nalalayo yung value at points surrounding the concerned point. Ibig sabihin, pag malapit ka lang doon sa gitna, yung value doon sa tangent plane, yung tangent plane mo, hindi pa siya masyadong malayo doon sa surface. Ibig sabihin yung, ang tawag dito yung local linear approximation, yung tangent plane. Ito yung function na dilaw, yan yung original na function. Yung local linear approximation serves as a good approximation to u of xy. Whereas in this case, pag nag-drawing ka dito ng bubungan, let's say lagay ka ng ganyan, ng bubungan na ganyan, makikita mo, no, for example, at this point, yung value ng tangent plane tsaka yung value ng graph ng function ay medyo malayo na, malaki na error nila. Unlike kapag differentiable, kapag kumuha ka ng points surrounding or near the center, the tangent, you cannot almost see the difference of the tangent plane and the surface. No? Pag malapit ka dun sa point of tangency. Naintindihan nyo? Naintindihan mo sinasabi ko? Halimbawa, wag na yung ganito na lang. Yung tuktok na, yung cone ng ice cream, baligtarin nyo. At this apex, hindi differentiable yung function na yan. Alam nyo bakit? Kasi pag na-drawing ka dyan ng tangent plane like that, no? Makikita nyo, at a certain point, pag nag-drawing ako ng vertical line, ito yung vertical line, ito yung functional value mo, pero ito yung approximation mo, malaki error. Diba? Yan yung error. Whereas, kapag ang graph mo ay smooth, at nag-drawing ka ng tangent, kasi yan yung graph mo, kunwari yung takip ng sphere, so nag-drawing ka ng tangent plane dito. Pag kumuha ka ng vertical line, malapit ka doon sa point of tangency, yung functional value mo, tsaka yung value doon sa tangent plane, hindi masyadong malayo. Yung error mo is small. Did you understand? And the error keeps getting smaller and smaller as you tend to the center or the point of tangency. So, naiintindihan niyo bakit itong tuktok nung nung cone, at that point hindi differentiable? Bakit dito sa tuktok ng, let's say, surface ng sphere, bakit differentiable, for example? Kasi nga makinis, ito hindi. Matutusok ka dyan pag inano mo yung kamay mo. Naintindihan niyo? Formally, kapag kayo nasa multivariable calculus, this is what we mean by being differentiable. Oh my gosh, anong meaning yan, sir? Okay. Let me explain this further na para maunawaan nyo kung anong meaning nito. So, in multivariable calculus, requirement na may partial derivatives ka, no? Bago ka maging differentiable. Ito yung additional condition para maging differentiable. Kailangan yung limit daw na ito ay 0. What does that mean? Kung mapapansin ninyo, if you make this substitution, yung x ginawa nyong x naught plus delta x, yung y ginawa nyong y naught plus delta y. Ito ngayon, ito yung u of xy. Kulayan ko ng dilaw. Ito naman, yung nasa loob ng bracket, pag ginawa ko yung kukulayan ko ng pula, that's u of x naught y naught plus ux of x naught y naught x minus x naught plus uy of x naught y naught y minus y naught. Ano naman yung pula na yan? Ito yung surface. Yung pula na yan, yan yung equation for the tangent plane. So basically, yung numerator, we are subtracting them. Ibig sabihin, we are measuring how far is the surface from the tangent plane. Dapat daw, when you, so this, the numerator is the error in the approximation. How about the denominator? What is this? The denominator is the magnitude of the error. Kasi yung delta x tsaka delta y, kumbaga, ito yung origin, ito yung 0, 0. Kung ito yung delta x, delta y, yung denominator, siya yung distance na to. How far is delta x, delta y from the origin? So, ang tawag nyo dito sa, saan ba to? Sa science, pag kayo nasa science, you call this the relative error kasi you're dividing the error with the magnitude of the sorry. This is the difference between the approximation divided by yung ano, yung gaano kalaki yung change nangyari. Ito yung parang delta y divided by delta x nung pang bata kayo. This time ito yung delta z over magnitude nung ano. Dalawa kasi nagbabago, hindi lang isa. Hindi lang si x, hindi lang si y. But rather, both x and y are now changing. Kaya to measure that total change, mini-measure natin yung magnitude nung yung distance nito from the origin, which is the denominator. Kailangan daw yung error na ito ay lumiliit na lumiliit. Pero, dahil may denominator, ibig sabihin yan, this goes faster to 0 than the speed of the error getting to 0. Ibig sabihin, mas mabilis dapat lumiit yung, ano ba ito ini-interpret? Ganun yan eh. Ang hirap ipaliwanag, no? Lalo't hindi naman ito yung subject natin. Kailangan yung distansya between the tangent plane and the surface gets smaller and smaller faster than sa paglapit ng delta x, delta y sa 0, 0. Sabihin, habang ito lumalapit sa 0, 0, dapat yung distansya ng tangent plane tsaka nung surface, mas mabilis lumiit kaysa sa paglapit nito sa 0. Naintindihan niyo yun in Tagalog? Kasi yung fraction nagsisiro, ibig sabihin yung numerator, mas mabilis mag-zero kaysa sa denominator. Kasi parehas nagsisiro yung numerator tsaka denominator. Para mag-zero ang limit ng fraction na yun, kailangan yung numerator mo will go to 0 faster than how your denominator is performing. Naintindihan niyo ba? Naintindihan ninyo? Yung sinasabi ko, pag may fraction ka, yung numerator nagsisiro, yung denominator nagsisiro, for the fraction to approach 0 means that the denominator should go faster to 0 than does the denominator. Did you understand? Ibig sabihin, mabilis lumiit yung distansya sa pagitan ng surface tsaka ng tangent plane. Hindi kagaya nito. Tignan niyo yung, nasa yung drawing ko doon. Pag nandito ka sa cone, yung distansya ng tangent plane tsaka ng surface, medyo mabagal lumiit. Lumiliit pero mabagal. In fact, malapit na malapit ka na sa 0 pero malaki pa yung distansya ng dalawa. Unlike kapag smooth yung surface mo, malayo ka pa lang sa doon sa center, no? Malayo ka pa lang sa center, maliit na kagad yung distansya. Naintindihan niyo why this limit measures differentiability? Ito yung ibig sabihin natin ng differentiable. In pictures, ganyan yan. Normally, I teach this in analysis 3 class. Okay. Ito yung tangent plane, ito yung surface. Pag sinabing differentiable, dapat yung surface mo makinis. Walang fold, walang bawal din ang yung matulis. Ano matawag doon? Mga sharp points. Pinagbabawal yun para maging differentiable. Ito yung sinasabi ko na hindi lang tungkol sa existence ng partial derivatives ang pagiging differentiable pag ikaw ay nasa higher dimension na. Okay? Sa calculus, ano na-prove natin? Alam natin sa calculus na kapag ang first partial derivatives mo ay nag-e-exist, hindi lang nag-e-exist, furthermore, continuous pa sila doon sa x naught, y naught. Using the mean value theorem, kung paano man yun gagawin, mapuprove niya na yung u of xy ay differentiable at x naught, y naught. So in other words, yung additional condition na required ay yung continuity ng partial derivatives. Kailangan pag kinuha mo yung partial derivatives, yung resulting function mo is also continuous. Kasi ang derivative, hindi laging continuous yan eh. And this is why we have the following converse. Ito, no? So u of xy, si v of xy, may first partial derivatives at hindi lang sila basta may first partial derivatives, continuous pa sila. Okay? And if this u and v satisfy the Cauchy-Riemann equations at the origin, then what? The resulting complex function is now differentiable at z naught, which is x naught plus I y naught. In other words, nako-conclude na natin yung differentiability because of the continuity of the first partial derivatives. So, hindi lang basta kailangan yung partial derivatives na satisfy yung CRE, kailangan sila ay mga continuous functions din. Naintindihan ninyo? So, halimbawa, let's take this as an example. Determine all the points where the function f of z equals z absolute z squared is differentiable. Kailan ito differentiable? So you might want to use the Cauchy-Riemann equations. Let z be x plus yi. Ano yung f of z? O di maging x plus yi times absolute x plus yi squared. Ano nga yung x plus yi squared? Ang x plus yi squared ay square ng square root. So, x squared plus y squared na lang. Okay? And then, identifying the real and the imaginary parts, this is what we get. I get ito, multiply mo doon, tapos pag ganon. That's x cubed plus xy squared plus I x squared y plus y cubed. Okay? Can I just place it here para hindi sayang yung space? Okay? So here, ang u of xy ay x cubed plus xy squared at ang v of xy ay what? X squared y plus y cubed, correct? Now, what I'm going to do is I'm going to take the partial derivatives. Ano yung ux natin? Ux is 3x squared plus y squared. Did I get it correctly? Uy. What is uy? Uy is 2xy. Tama ba si sir? 2xy? 2xy? Vx. Anong Vx? Ang Vx ay 2xy and ang Vy ay x squared plus 3y squared. Did I do the computations correctly? Tama? Can you agree? Agree ba kayo yung derivatives? Okay. Note that. So this is the important thing. Observe that the partial derivatives are all continuous everywhere as they are polynomials. Kasi polynomial sila. Diba? Lahat ng mga polynomial functions everywhere, continuous. Sila ang ano, sila ang standard natin pagdating sa usapin ng continuity. Automatic sila yon. Okay? These partial derivatives are continuous. Therefore, by the converse of the theorem that we have, magiging differentiable si f precisely when u and v satisfy. Kumbaga, nagiging enough na yung pag-satisfy ni u and v sa Cauchy-Riemann equations. Kasi continuous naman na yung first partial derivatives. No? So therefore, as a conclusion, f of z is differentiable at points z0 where u and v satisfy the Cauchy-Riemann equations at x naught y naught. Kung saan man masasatisfy yung Cauchy-Riemann equations ay ano, differentiable na yung function doon. Kaya tingnan natin, kailan masasatisfy yung Cauchy-Riemann equations? Tingnan natin ha. CRE are satisfied if and only if. Kailan masasatisfy? Ano yung Cauchy-Riemann natin? Ux is Vy and Uy is minus Vx. Tingnan natin yung mga na-compute natin. Ang Ux natin ay 3x squared plus y squared equals x squared plus 3y squared. Yung Uy natin naman ay 2xy while ang minus Vx ay minus 2xy. Ang gagawin nyo ngayon, isa-solve nyo lahat ng mga xy na nakakasatisfy dito sa dalawang equations na to. Para malaman natin kung saan-saan magiging differentiable si f of z. Did you understand? Isa-solve nyo lahat ng mga x and y na nakakasatisfy sa system na ito. But you see, this system is not really hard to solve. Kasi tingnan nyo to, masisimplify yung unang equation into 2x squared 2y squared. Kasi ito, yung second equation magiging 4xy equals 0 or xy is 0. Yan, simplify natin ha. Cancelin yun 2. Pag ang x squared equals sa y squared, mga real numbers to, ang x mo plus or minus y. Diba? Tapos ang xy mo ay 0. Okay. Ano-ano yung mga xy na nakakasatisfy dito? Kung i-observe nyo itong mabuti, yung unang equation, anong graph niyan? Ito yung graph niyan eh, x is y, tsaka x is minus y. That's the first equation. Yung second equation mo naman, kapag xy is 0, dalawa lang ang true. X is 0 or y is 0. Ang tanong, saan nag-intersect yung dalawang pairs of equations na yan? Saan nag-intersect? Ha? Saan nag-intersect? Very good. At the origin. Dito lang nag-intersect. Therefore, magkakatotoo lang yan if and only if x and y are both 0. So, anong masasabi natin sa function na ito? Correct. Therefore, f is differentiable only at 0, 0. Ano ba yung 0, 0 sa complex plane? At z equals 0. So, kagaya nung naunang example ko, itong function na to magiging differentiable lamang siya only at the origin. Okay? Malapit na tayo matapos, pero yeah, there are a few more slides. Naintindihan niyo ba? Paano ginagamit yung Cauchy-Riemann equations? Isa-solve yung mga xy where the Cauchy-Riemann equations are true. No? Para ka magsosolve ng system of equations para malaman mo kung saan nasasatisfy Kung continuous naman doon, yung first partial derivatives na yan, you can already declare differentiability for the complex function. Okay? So we are now at a position to define anong ibig sabihin natin ng word na holomorphic ang isang function at a point. Okay? So when we say that the function f of c is holomorphic at z0, this is just our fancy way of saying that maliban sa differentiable si f of z sa z0, kailangan differentiable pa siya sa paligid ng z0. Kumbaga, hindi ka lang dun sa point na yon differentiable. Dapat sa paligid pa nun, differentiable ka rin. Ang tanong, bakit ba nagiging issue to sa complex analysis, sir? Ang sagot, kasi marami tayong example where the differentiability happens only at a point. That's very sad, no? Imagine mo yung function mo sa isang point lang differentiable and nowhere else. That's kind of sad. Kaya nagiging issue sa complex analysis kung differentiable ka, kung holomorphic, sabihin hindi ka lang doon differentiable. Differentiable ka pa sa paligid. Kasi tingnan yung definition natin. F of z is differentiable at z0 if f of z is differentiable at every point on some open set containing z0. Kumbaga, if this is your point z0, para maging holomorphic ka dyan, hindi ka lang dyan basta holomorphic, at hindi ka lang dapat dyan differentiable. Dapat differentiable ka rin on some open set. That being open, meaning may isa pang open disk around it, no? Magkakasya dyan. Sabihin, maluwag. Maluwag yung set mo. Hindi siya makitid. Okay? So, in other words, hindi ka lang sa Z0 differentiable. Differentiable ka pa at points surrounding Z0. If this open set can be proved to exist, then it is holomorphic at Z0. Kung holomorphic naman yung function mo at every point in the complex plane, kagaya ng mga polynomials, na ito naman sila, no? Ang tawag sa kanila ay entire function. Okay? We use the word entire for functions which are holomorphic everywhere. Sa makatuwid, alam nyo, walang pinagkaiba if U is open, no? Walang pinagkaiba yung differentiability at noun form ng pagiging holomorphic. F is holomorphic on U if and only if F is differentiable on U. Wala talaga silang pinagkaiba kapag sets ang pinag-uusapan. Pag open set ang pinag-uusapan. Kasi kapag holomorphic ka on U, pag differential, kasi ito, laging true ito. Diba? Kailangan kasi kapag holomorphic ka, dapat differentiable ka doon sa gitna. Kaya dapat differentiable. Pero yung converse ang hindi laging totoo. Kasi may mga examples tayo na differentiable ka lang dun sa point na yun and nowhere else. So, hindi yan holomorphic dun. Correct? Kaya kapag pinag-uusapan ay open sets, kapag differentiable ka on an entire open sets like this, holomorphic ka pa dyan. Kasi pag kumuha ka ng arbitrary point in an open set, laging may open disk around it, nandiyan pa rin. Kaya hindi ka lang sa Z-not differentiable ka rin sa paligid, therefore holomorphic. Kaya wala naman talagang pinagkaiba ang salitang holomorphic at differentiable kung sa isang open set nangyayari ang lahat ng bagay. Magkakatalo sila usually kapag ang pinag-uusapan ay isang point lang. Okay? Ayan. Another remark, we can say that F is holomorphic at Z-not if and only if you can find some disk around Z0 where F is differentiable on that open disk. Kasi that open disk is an open set. So for example, polynomial functions are entire as always. Halimbawa, this function 1 over z to the 4 plus 1, kailan ba yan hindi differentiable? Hindi lang naman yan differentiable basta kapag 0 yung denominator eh. And tanong, kailan yan nangyayari? at the points equal to any of the complex fourth roots of -1. Kasi pag ito ay 0, it's like saying that z to the fourth is -1. So kung gusto nyong malaman precisely kung saan ito hindi holomorphic, kung saan siya hindi holomorphic, kukunin niyo yung mga fourth roots ng -1. Paano yun kinukuha? Tinuro ko sa inyo yun dati. Sulat niyo in polar form. Doon papasok yung polar form kasi mas madaling kunin yung fourth roots pag naka-polar form. Okay? Yan. Ito yung sinasabi ko. Nagkakatalo ang differentiability at holomorphy kapag ang pinag-uusapan ay isang point. Kasi kagaya na itong function na ito. Kanina yung function na ito, na-prove natin to be differentiable at 0. Pero it is not differentiable anywhere else, only at the origin. Therefore, it is not holomorphic at 0. Naintindihan ninyo? The function is not holomorphic at 0 because differentiable ka lang sa 0. Pero walang neighborhood yung 0 where you are differentiable. Kasi yung function na yan, ang katotohanan, dito lang siya differentiable. Kahit na anong open set ang kunin mo around 0, no? There's no chance na magiging differentiable yung function nyo sa open set na yan kasi dito nga lang siya differentiable. Did you understand? Did you understand? Pag sinabing holomorphic at a point, hindi ka lang dun differentiable, sa paligid pa. Hindi naman nire-require na sa buong paligid. Basta on some paligid or on some neighborhood. Kaya nga, if there exists an open set. Did you understand? Okay? Naintindihan yung pinagkaiba ng word na differentiable at holomorphic? Ang pag holomorphic, differentiable. Pero pag differentiable, not necessarily holomorphic kasi holomorphic is much more, no, than just being differentiable. Nagre-require siya ng differentiability not only on that point or at that point, but also on some neighborhood of that point. Okay, what's next? What's next is this. Meron tayong, magta-time na pala, no? May theorem kayo dati sa calculus. Gagawa natin ng versions ng version sa complex analysis ito, no? From calculus, if I is an interval, and f prime of x is 0 for all x in the interval I, sige nga, give me a conclusion. Anong conclusion yan sa calculus? If you are in calculus, you saw this, can you give me a conclusion? I is an interval and the derivative of the function f on that interval is all 0 at any point. What can you say about the function? Can you give me a conclusion? Pag 0 raw ang derivative ng isang function on an interval, what can you say about the function? Very good. F is constant on that interval. Okay? Take note that this result was proven using the mean value theorem, but the result is not true if I is not an interval. Okay? Halimbawa, for example, ang I kunwari ay yung union ng -1, 0, tsaka 0, 1. Okay? Not an interval kasi putol yan, di ba? -1, 0, 0, 1. Putol siya. So, it's not an interval. Hindi siya connected. Ang magic word dyan talaga ay yung word na connected. Kasi sa real number line, yung word na connected, it only means in an interval. Pag dinefine mo yung function like this, kunwari dinefine ko siya as -1, if x is here, and 1, if x is there, ang graph ng function yan, ganito. Ganyan, no? So, kung mapapansin nyo, si f prime of x is 0 for all x in I, but f is not constant. O at any point in I, dire-diretso lang naman yung function. Pero hindi siya constant. Kasi yung buong set na to, hindi naman siya interval. True lamang yung result na ito, it is because I is an interval. Did you understand? May role na ginagampanan yung pagiging interval dyan. At ang proof na ito ay gumagamit ng tinatawag na mean value theorem sa calculus. Okay? Kung di nyo naaalala, di hindi. Let's pretend na naaalala natin. Sa complex analysis, meron niyang version, but the proof is quite long. We cannot do it right away. This is the main theorem. Yan. If you have a function, f of z, that is holomorphic on a domain D. Ayan na tayo. Gumamit na tayo ng word na domain. Ano nga ang ibig sabihin ng word na domain? Hindi ito domain ha, ng function. Pag sinasabi ni sir na domain, ang ibig sabihin nito, this is an open set and a connected one. Connected and open. Halimbawa, yung annulus na ito. For example, itong annulus na to, it's a domain kasi it's open and connected. Okay? Right? Pero for example, yung closed disk, not a domain kasi hindi siya open. Diba? Right? Or ano pa yung mga hindi domain? Halimbawa, yung putol-putol yung set mo. Halimbawa, yung complex plane without the real. Although this is open, but this is not connected. Kasi parang tinanggal mo yung real number line sa complex plane, magkakaroon ng ilog dyan sa gitna, no? Pagtatawid ka from one point to another, ayun. Diba? You have to cross that river. So therefore, these are not examples of domain. Ang domain dapat open and connected. Okay? Ang sabi, kung ang derivative ni f ay 0 for all z in the domain D, then we can prove that f of z is constant on that particular domain. Okay? But because the proof is long, we will do it next time. Okay? Also, meron pang ilang few na lessons tungkol sa level curves. Yeah. Sige. Gawin natin to next meeting. This and the last one. And next meeting, ano bang next meeting? Stop ko muna yung recording ha.